The first part of this new chapter deals with definitions that we have seen before in the previous chapter. A sequence is a set of terms in a defined order with a rule for obtaining each term. It's often written like this: U1, U2, U3 all the way onwards. And we denote the rth term as UR. A sequence can be finite or infinite. Let's take a look at some examples. In part 1, you see 1, 2, 3, 4, 5, all the way to 100. Now this is a finite sequence with 100 terms. The first term, U1, is equal to 1. Second term, U2, is equal to 2. And all the way until the last term, U100, is 100. Now we are often required to write down the rth term of a sequence. In this particular case, UR can be written as just R, where R is 1, 2, 3, all the way to 100. In the next part, you see a sequence of numbers 2, 4, 6, 8, 10, 12 onwards. Now this is an infinite sequence. U1, the first term is 2, second term is 4, and so on. And if we want to write down the general term, UR, we can write it down like this. UR is 2R, where R is 1, 2, 3 onwards. Let's take a look at more examples. From part 3 to part 5, we want to state whether the following sequences are finite or infinite. And we want to list down the first term, third term, eighth term, and the general terms of the sequences. Now in part 3, it is obvious that this is a finite sequence. It is finite because there is a last term, 99. And you can easily list down the first term, 1, third term, 5, and the eighth term, 15. And if you look closely at this set of numbers, you should be able to see that it's actually the set of odd numbers from 1 to 99. And we can always write down an odd number in this manner. And if we want to write down the rth term, we can always write UR is 2R plus 1, where R is a number from 1 to 50. We can also write an odd number in this form, 2R minus 1. And if we choose the set of R values to run from 0 to 49, then we can write the general term UR plus 1 as 2R minus 1. Both forms are similar. Let's take a look at part 4. Now in part 4, we see an infinite sequence. It is infinite because there is no last term. And to write down the first term is pretty easy. First term is 2, the third term is 8, and if you continue the sequence of numbers, you can easily work out the eighth term to be minus 256. To write down the general term, I hope you can see this pattern. The first thing to note is every term has got a different sign from the preceding term. You have plus 2, then you have minus 4, you have plus 8, and minus 16. So the general way to show this change in sign is minus 1 to the power r. And if you notice, the number after the sign is always a power of 2. The first term is 2 to the power 1, the second term is 2 to the power 2, and so on. Now, look at the sign. The sign of the odd term is always positive. Plus 2, plus 8, plus 32. It tells you that I should put a minus 1 or plus 1 here, because this will guarantee that the odd term is always positive and the even term is always negative. So the rth term, UR, can be written like this. Now you can try part 5 on your own. It is not too difficult to see that the 8th term is 1 over 8 times 9. Why is that so? If you look at the first term, it's 1 times 2. If you look at the second term, it's 2 times 3. If you look at the third term, it's 3 times 4. So if you work out this way of writing down the numbers, it's not difficult to see that the 8th term is 1 over 8 times 9. In fact, you can write down the general term UR as 1 over R times R plus 1.